Shesi. Okay, here we'll be starting with again a quick revision of chapter 1 units and dimensions. So here we have dimensional analysis. I'll tell you a small topic from the dimensional analysis. So in the dimensional analysis, we will be checking that we can use our methods of dimensional analysis to find if or to check, we can check the correctness of a formula. Check the correctness of a formula by using the dimensional analysis. We can use dimensional analysis to derive the formula.
Sir, till which date do we have this bridge course?
Yeah,
Sir, till which date do we have this bridge course?
till which date? I think about maybe April or May only. From May we are starting with the fresh 11th class. Okay, May 1 we are starting with the fresh class of grade 11, I think. Okay. So
Okay, sir.
I'll confirm with ma'am and then tell you, or ma'am will disclose. I think within 1 to 2 days, ma'am will inform you also. Okay. So yes, we can use this dimensional analysis to derive a formula. Knowing the dependencies, just knowing the dependencies, that on what factors does the formula depend, we can find out the correct formula. So to derive a formula. Let us see how we use these relationships. So first of all, suppose I want to check whether a given formula is correct or not. So any formula, if it's given, so the formula must be dimensionally correct. Dimensionally correct means if the left hand side of the formula, for example, suppose I take here the formula of time period of a simple pendulum. So the time period of simple pendulum is given by t equals 2 pi under root L by G. So this is the formula for the time period. Now, if I check the correctness of this formula, so this formula should be dimensionally correct. That means whatever are the dimensions on the left hand side, the same should be the dimensions on the right hand side. Okay. So if you observe here on the left hand side, we have the dimensions here M0, L0 and T only. So on the left hand side, it has only the dimension T. There are no other dimensions which are present on the left hand side. Now, if I get from the right hand side, so on the right hand side also, the formula should have the same dimensions. Okay. So if I follow here, so on the right hand side, I check here the formula. So for the right hand side, we have 2 pi is a constant and it does not have any dimensions. It does not mean that the constants do not have dimensions. There are certain constants which do have dimensions, but this 2 pi is a constant which does not have any dimensions. Okay. So 2 pi is just a constant without any dimensions. So we ignore this 2 pi and we can write here the dimensions of L. So for the dimensions of left hand side, I will write here whole to the power 1 by 2 as it's a square root. So I will write it whole to the power 1 by 2. L will have the dimensions L and this G will have the dimension of LT minus 2. Since this is acceleration and dimensions of acceleration are LT minus 2. Okay. Are you getting
Yes,
any
sir.
doubts here? No. We have just put here the dimensions of acceleration due to gravity. See the dimensions of acceleration units are meter per second square and its dimensions are LT minus 2. So the same I have put here. Now if we simplify this, L and L cancel. I get here t to the power 2. T has the power minus 2 in the denominator. It goes to the numerator has the power t to the power plus 2 and whole thing having the power 1 by 2. Now if I simplify, I'll get cancelled and I just have t. I just have t here, no other dimension, which I can write as M0, L0, and T. So can I say that the dimensions of left hand side and right hand side are the same? Yes.
Yes, sir.
Yes, the dimensions on the left hand side and the dimensions on the right hand side, they are same, and hence the formula is correct. Now, can you verify and check the correctness of this formula? If I have impulse, I have the formula of impulse, and I want to verify that whether it's correct or not. So the formula of impulse is something like this. I am giving it. I have impulse, which is given by force multiplied time, and it should be equal to mv by t minus mu by t. So is this formula correct? You have to verify that whether the given formula is correct or not. Okay. So on the left hand side, see, whatever be the dimensions of this, whatever be the dimensions of this, the same should be the dimensions of this also. It's just like you can add the same variables. Like if you have, suppose I tell you to add, you have 10 meter, you have 5 seconds, you have 15 kilograms. So can you add all these three together? Yes. Just one, can you add all the three things together? 10 meter plus 5 second plus 15 kilogram. Can you add all the things together and give me some answer? The answer is no, you cannot add them. To add them, all of them, they must be in the same dimension. You can add meter to meter, second to second, kilogram to kilogram. If they are having different dimensions, so you cannot add them. Okay. So here, whatever should be the dimensions of one physical quantity, if they are added or subtracted, so both of them, they should be having the same dimensions. So as we can observe, they both are having the same dimensions, and the dimensions of each physical quantity should be equal to the dimensions on the right hand side. That means the dimensions of force multiplied by time should be equal to the dimensions of mv by t. Now you verify and check, are the two dimensions the same? Yes. Can you verify? I'm waiting for your answer. Try to verify that if the dimensions on the left hand side, okay. So Shesi has answered. She says that they have different dimensions. The dimensions are not the same. Now, if the dimensions are not the same, that means the formula is incorrect. Okay. So you can say that the formula is incorrect. With 100% surety, you can say that the formula is incorrect. Okay. See here on the right hand side, if on the left hand side, if you observe the dimensions, on the left hand side, you will get the dimensions m, l, t minus 1. This will be the dimension on the left hand side. And on the right hand side, you will get the dimension as m, l, t minus 2. So both the dimensions, they are not the same. The dimensions are not equal. Okay. Hence, the formula is incorrect. So to find this out, if we suppose, okay, let's check out this formula then. This one is incorrect. So can we tell for this impulse given by the formula force multiply time and should be equal to mv minus mu. Now check, is the formula dimensionally correct? Check the correctness of the formula dimensionally. Okay, let's check it out. Okay, got it. So you can check here. I am posting another question here from NCRT. Okay. Okay. Also, I will try out some more questions from this chapter, since we have done very less questions from here. Okay. Okay. So you have to consider this. Let us consider the equation 1 by 2 mv square is equal to mgh, where m is the mass of the body, v its velocity, g is the acceleration due to gravity, and h is the height. Check whether this equation is dimensionally correct or not. So these two questions we are going to do right now. See, so you have this question and adding another question. So let's try to do this first one. I want you to do this question number 15 first. Okay, I think you have got. Yeah, Shashi says both are energies, so they are dimensionally correct. So they are energies, but you have to verify them. Okay, you just verify it once. Okay, verify it and see that are their dimensions the same or not. So the dimensions, however, should be the same, but just verify. So on the left hand side, you will leave out this 1 by 2, that's a constant. Okay, so Shashi is very quick in answering. She is giving answers. Just one. Okay, Dhanunjay.
Yes, sir.
Okay, check out the dimensions on the left side. Did you get this question?
Yes, sir. I
Oh,
found for MGH. I didn't find for MGH.
okay, fine for this also. You can leave this 1 by 2 since 1 by 2 is dimensionless. So you can leave this 1 by 2. So LHS will have the dimension m, mass will have the dimension m, and
Sir,
since
I'm showing
velocity has the dimension
T1
L, LT minus 1, so it has to be LT minus 1 whole square. So it has the dimension m L2 T minus 2. Right? Are you getting the same dimensions for RHS also?
Yes, sir.
Yes. Now see, for the second question, just read the second question. Read the second question. For this, your answer is yes. For this one, consider a simple pendulum having a bob attached to a string that oscillates under the action of force of gravity. Suppose that the period of oscillation of the simple pendulum depends on its length, mass of the bob m, and acceleration due to gravity. Derive the expression for its time period using method of dimensions. So you have to use the method of dimensions to obtain the formula for the time period. The question is not giving you the formula, but it tells you to find out the formula for the time. It has given some dependencies. The dependencies are given as it is. It says that the time period is proportional to the mass. It is also proportional, the time period is also proportional to the length, and the time period is also dependent on acceleration due to gravity. It depends, but it does not give proportional, how proportional it is. So if it depends on mass, so let us say it depends on mass to the power A. Okay. Suppose then it says it depends on the length. So let us say it depends on length to the power B. And suppose the next thing is that it has given that it depends on acceleration due to gravity. So it depends. So again, we write G to the power C. Have you understood this? How we have taken this from the question? The question says that the time period is dependent on mass, it is dependent on acceleration due to gravity, and it is dependent on the length. Okay. So we have written the statement from the question. Got it, Dhanuja?
Yes, sir.
Okay. Now we can combine all the factors and we can write together as T being proportional to M to the power A, L to the power B, and G to the power C. So in this way we can write and we can say, okay, okay, very good. K multiply M to the power A multiply L to the power, yes, that's correct, Shreyasi. And now we can write the dimensions. On the left hand side, we will write the dimension of each physical quantity. So here, the dimension of mass we can write as M. So write M to the power A. The dimensions of L are L only, so we write it as L to the power B. The dimensions of G, that is acceleration, it will be LT minus 1. And it will be to the power C. Okay. So here you have the time period. Now, just solve the LHS. We get here M to the power A, L to the power B plus C, and T to the power minus C. Okay, Shesi is very quick in answering. She is providing the answers. Okay, very good. Very good, Shesi. Jaswant, very good. You joined. And see, join on time. And one thing I always like to call to all the students. See, whenever you have some urgency, like you have to some guests are there or something, any emergency, you may have to discontinue the class at that moment. So just inform me for 1 second, interrupt me and inform me, sir, I need to leave, I have some urgency. Okay, so that suits better.
Sure, sir.
Okay, so that's better, you can go. Just assume a physical class going on and you just standing up and leaving the class, coming in. Here we assume that yes, sometimes maybe because of network issue you went off, but it cannot be otherwise. So whenever you need to go, you need a break, just inform and you can. Okay. So you see, with this formula, we have to derive this formula. Now we have got the dimensions. See, we have simplified the left hand side. Here you have T, and here we have the dimensions all simplified. See, here you have L to the power B. If you open the bracket, you will get L to the power C. So we have written L to the power B plus C. T to the power is minus C just by opening the bracket. We have written the dimensions here. And we also write the dimensions here. Okay. So on the left hand side, you have the dimensions as M to the power 0, L to the power 0, and T to the power 1. These are the dimensions on the left hand side. On the right hand side, you have the dimensions of M to the power A, L to the power B plus C, and T to the power C. Now, by comparing both of them, since the formulas have to be dimensionally correct, so we can compare the values. We can obtain the value of A. So, very quickly, we can say what should be the value of A. Tracy has already answered. The value of A is 1. Very good. So the value of A is 0. We have A as 0. And we get minus C equals to 1. So that implies C equals to minus 1. And we have here B plus C equals to 0. If you put the value of C here as minus 1, so you will get the value of B as plus 1. By using the value of C as minus 1, we put here in the second equation and we get B equals to 1. So all of you have got understood how we obtained the value of this A, B and C. We had to obtain these values A, B and C. Now we have obtained the values. We can put the value of A, B and C in this formula, where we had written initially that T is proportional to M to the power A, L to the power B, G to the power C. So we can put all the values of A, B and C here. By putting the values, we get T is proportional to M to the power 0, L to the power 1. Is it 1? Oh, sorry.
Yes.
Oh, sorry, I made a mistake. There is a mistake in the question. In the solution I have gone. You just correct it and do it again. Here my mistake is I have put LT minus, this has to be minus 2. The formula of G is LT minus 2. So just rectify it and solve again. Tell me the values of B and C again. The values of B and C are incorrect. Just obtain them again. It's LT minus 2. So accordingly, you will have your minus 2C, here also minus 2C, and we can conclude minus 2C to be equal to 1, and hence the value of C as minus 1 by 2. Then you get the value of B. Using the second equation, you get B as, you can put B plus C to be equal to 0. So B is B minus 1 by 2 will be equal to 0. So we get B equal to 1 by 2. Now if you put the values, you get your answer. Okay. So we can put the values finally and we'll get the answer. See, we put here T proportional to M to the power 0, L to the power 1 by 2 and G to the power minus 1 by 2. This is how we have done. We have put the values of A, B and C. You should have your pen and paper to keep on solving, putting the values. Okay, so we got the value T proportional to, this is 0, so it vanishes. And you have under root L, G to the power minus 1 by 2, it prevents under root of G in the denominator. And you can write this as T proportional to under root of L by G. You can remove the proportionality, obtain the value of the constant. So we get T equal to the constant, which is 2 pi under root of L by G. So by the method of dimensions, we have obtained the formula. You can write down this formula as directly like this. T equals to a constant K multiply under root L by G. Then also it's correct. It's perfectly correct if you do up here. So I hope all of you have understood. Let's see some more questions. I'm getting some more questions. Okay. Just 1 minute, I'm sharing in your group, and then we'll be solving these questions from the dimensional analysis. So, you can check your group. Over there, you have got some questions, and in those questions, look at question number 6. Look at question number 6. We'll start solving from question number 6. You can do other questions 1, 2, 3, 4, 5 for your practice. We start from question 6. Yes, Shesi, if you do not know the value of the constant, you can put just over there k. Okay. So now just check your WhatsApp group. I have posted some questions. Open up that. I'm also opening up the question. We'll start from question number 6. You can start solving. If you have got question 6, you can start solving that. Let's share again. I just want to show you this question 6. You can do the remaining questions. And I think you are able to attempt the questions which were given yesterday. Yes. Okay. Okay, I have got one of the answers. Shesi is very quick in answering. Let's see. Here I am focused on question number 6. See? It says the electric field is expressed as E equals to F by Q, where F is electric force and Q is electric charge. Then what is the dimensional formula for E? You have to give the dimensional formula for E. Remember, the SI unit of charge is Coulomb, but that is not the dimension. That is not the fundamental quantity. You have to express in terms of fundamental quantities. So we can write here electric field E to be equal to F by Q. This is given question number 6. Now, force we know, the dimensions of force we know, but we do not know the dimensions of charge. We can find out the dimensions of charge from the formula of current, as we know I equals to Q by T. So I multiply T will be equal to Q. Why we are using this? Because current is one of the fundamental quantities. Time is also the fundamental quantity, where a charge is not a fundamental quantity. It is not a fundamental physical quantity. Okay. So just putting the values, we can put here A and time is second. So this is AT are the dimensions of charge. Now we can get the dimensions of electric field. So E will be equal to MLT minus 2 divided by the dimensions of. So we have to put here MLT minus 2. Okay. So divided by the value of Q, which is 80. So we can put it now. M L T minus 3 A to the power minus 1, and this is the dimensions of the electric field E. So I hope you have understood him. Okay. So do try to do the remaining questions which have been shared. I will share some more questions with you. Okay. Yeah, Shashi, thank you. You got the answer for 7th one also. I'll be checking this tomorrow. Okay. Bye, everyone.